I am Anil Kumar. Welcome to my series on radicals. We are trying to understand some operations with radicals so that we can do better with quadratic functions. To solve a quadratic equation, sometimes you must have seen this square root thing. We'll understand how to work with it. Based on that, we have 8 questions here. Take it as a worksheet to practice. All the questions should be solved without calculator. So make a note of these questions. Here are the other questions from 4 to 6, and then the last two, 7 and 8, right? So I hope you have made a note of these questions. You can always pause the video, answer these questions, and then look into my suggestions. Now, before we begin answering them, let's briefly talk about radicals. So we'll understand what are radicals. So these are different topics which I am going to discuss. I'm going to keep this very simple, but to begin with, let's first understand the word radicals itself. You must have seen something written as within this root sign a, let's say n, right? So something like this, if you see, then that is called the radical. Now here, n is the index. So that's a technical name given to the root, nth root, right? So we say nth root, and a is called the radicand. When we evaluate this value, then we can also say, well, this radical, nth root of a is equal to b. It really means that a is equal to b to the power of n. That is how it has to be treated, right? Now, most of the time, you will see something written for n, but sometimes you may also observe that n is missing, right? In that case, default value is n equals to 2, and that is default. This is called square root. So if I write square root of a equals to b, it really means that a is equal to b square. So that is how it is related, correct? Our focus here will mainly be on the square root where n is equal to 2. So most of the time you'll just see this symbol. As you have seen in the whole exercise, what we have here is all square roots, right? So the index here is 2. Perfect. So we have understood what the radical is, and we'll focus more on the radical which will be of the form square root of a, which is called square root. One more important thing which I should mention here is that in this radical form, if n is even, then a should be greater than or equal to 0, and as far as b is concerned, that will also be greater than or equal to 0. If n is odd, then if n is odd, in that case a and b belongs to real numbers, right? They could be negative also. Okay. Now let's look into the other terms which are entire radical. So when we say entire radical, that means a number which is totally written within radical sign kind of like this, where it is written like this. This is entire radical, right? Everything is within the radical sign. Mixed radical will be, if I write square root of 18 as 9 times 2, I could also write this as 3 square root 2. Now that will be the mixed radical. When we talk about like radicals, we think about terms like, let's say if I write 5 square root 2, 5 square root 3, and 3 square root 2. In that case, 5 square root 2 and 3 square root 2 are like radicals. So radicals are like if you have similar thing within the radical sign, not when outside is same. Got the idea? So that is called right like radicals. We can actually add or subtract the like radicals, and that is how we'll be simplifying. We can change from one form to the other. We'll take up that in our worksheet. We can multiply them and do all these operations, right? So I hope these basic concepts are clear. Now let us see how to solve these examples one by one. So I'll begin with the very first question here, which is we need to express each of these as mixed radicals in simplest form. Now square root of 18. See, square root of 18 can be written as 9 times 2. Now 9 is a perfect square, right? So we could write this as square root of 9 times square root of 2, right? So we could write like this, square root of 9 times square root of 2. Now square root of 9 is 3, and therefore we could write this as 3 square root 2. Most of the time you can actually directly write this. Okay, now let's get to the next example, which is 72. To split it into two parts, we are looking for a factor which is a perfect square. 36 is a good number and it is a perfect square. 36 times 2 is 72. And we know that 36 is 6 square, right? So think like this. It is 6 square times 2, right? So 6 can be taken out and this could be written as 6 square root 2. Does it make sense to you? So that is how we can now write this as a mixed radical, right? Now you can do these two. So square root of 50 can be thought of as 25 times 2. 25 is 5 square, so I can write this as 5 square root 2. 98 is what? Is 49 times 2. 49 is 7 square, right? Times 2, and therefore we could write this as 7 square root 2. So I hope this exercise is absolutely clear. Now the next part here is to express each mixed radical as entire radicals. So we have to do the reverse. You see, 25 was inside, we took out 5. Inside was 5 square. So when I have to write 2 square root 10, then basically it means 2 square times 10, right? So that should be written as 4 times 10, which is 40. That is what it is. So when you take the term which is outside within the radical sign, it becomes square of that number, right? So this could be written as 9 times 21, and now we can multiply 21 by 9. So 9 times 1 is 9, 9 times 2 is 18. So we get 189 square root. 3 times 7 means 9 times 7, and that should be equal to 63. And here 5 times 5 is 25 times 5, correct? So what I'm doing here is I'm multiplying 25 by 5, which is 125. Clear? So that is how you can easily do these questions, right? Let's move on and take the other questions. Question number 3. We need to simplify. As I said, we could add and subtract once we have like radicals. Now here, it doesn't look like, but we can simplify, right? 8 can be written as 4 times 2, right? So think about it like this. 4 times 2 is 8. That is multiplication. Here we have 9 times 2, right? Now 4 square root is 2, so I could write 3, 2 outside, square root 2, minus, this is 3, right? So 3 outside, square root 2. Now they are the like terms. We have square root 2, square root 2. These are like terms. 3 times 2 is 6, so we have 6 square root 2. Take away 3 square root 2, which is 3 square root 2. So we get our answer as 3 square root 2 for the given operation of radicals. Clear? Next one here is 2 square root 50 minus 18. Now 50 is 25 times 2. So we could write this as 2 times 5 square root 2 minus, this is 9 times 2. So we could directly write 3 times 2, right? 9 times 2 is 18. Does it make sense? So what we have written here is 10 square root 2 minus 3 square root 2, which is equal to 7 square root 2. Perfect. Now we have 3 terms here, let's do them. 2 times square root 50, so 2 times square root 50 is 25 times 2, 25 square root is 5, 27, 9 times 3, 3 square root 3, plus 3 times 16 times 2, right? So which is 4 square root 2. So we do get like terms here also. These are the two like terms which can be combined, correct? So we could write this as, this is 10 square root 2. Bring this together, which is plus 12 square root 2. And here we have minus 3 square root 3. 10 plus 12 is 22. So we get 22 square root 2 minus 3 square root 3. So that becomes simplified form for the given radicals. I like you to try this on yourself, right? Now D is 5 square root 48 minus 1200 square root plus 3 times 12. Okay, let's try to split them and write the way we had been doing. 48. We're looking for a perfect square. 16 times 3 is 48 minus 1200. Well, 12 is 4 times 3 times 100, right? So that is 1200 plus 3. 12 could be written as 4 times 3, correct? So we got a perfect square here. 16 square root is 4. Taking out 4, that means 5 times 4 square root 3 minus 4 means 2. Outside, 100 means times 10, and within radical we have 3. 4 square root is 2, so we'll 3 times 2, and within radical we have 3. 20 square root 3 minus 20 square root 3, and what is this? Plus 6 square root 3. Now that cancels, and we get 6 square root 3 as our answer, correct? So that is how we are going to simplify it. Let's continue. Take up question number 4. We'll try to see what happens when we divide. Well, it is kind of same thing. So you are writing this as equal to 2 over, we can write like this. First step, right? Let's write like this. So these radicals and radicals, you can divide, the numbers you can divide. So we get 1 over 3 here, and within the radical, what we have is 50 over 18. Can you simplify this a bit? Well, dividing both by 2, we get 25 over 9, correct? Cancelling by 2, right? So we can divide both by 2. 2 is a common factor. And that gives you 1 over 3. 25 square root is 5. And 9 square root is 3. So we get 5 over 9 as our answer. Clear? Next one is to multiply. Now when you multiply the numbers with the numbers, and within the radical with the radical. So we get 2 times 3 as 6, and within the square root we get 7 times 21. So we get 7 times 21. Now to simplify, we could split 21 as 7 times 3. So what we have here is 7 times 7. One of them can be taken out, right? So we could write this as 6 times 7 within square root 3, which is equal to 42 square root 3. Perfect? You get the idea. So that is how we could simplify it. Now let's do this operation. Within the bracket, we have 2 square root 3 divided by 32, and outside we have 3 square root 24. Right? So let's do this operation first within the brackets. You have to apply the rules, right? 3 square root 24. Now 24 could be simplified. You could write this as 6 times 4, right? 24 divided by, here we have 2 square root 3 divided by 32. Think like this. 2 square root 3 divided by square root of 32. Correct? Now this could be simplified. 2 outside. So we get 3 times 2 square root 6, and everything is divided by all this. Now all this is what? 32 can be simplified as 16 times 2, right? So we could multiply with reciprocal, right? So we could write this as square root of 32 over 2 square root 3. We could do this. Perfect, right? Now square root 32 is 16 times 2. So we'll write this as 6 square root 6 times, this is 16 times 2. 16 is 4 square root 2 over, we have here 2 square root 3. Now see what can cancel. We can cancel this number 2 with 2. And this 3 can go into 6, right? So what we get here is 6 times 2 as 12. And this square root, when you multiply, it is 12. So within square root, we have 12 divided by 3. Perfect. Which is 12 times square root of 4. Square root of 4 is 2. So we get 24 as our answer. Is that clear to you? Slightly more complicated. However, I hope you understand the steps, right? So you could divide this. Division is as good as multiplication by reciprocal, and then simplify, correct? Now, since this was in bracket, we did this first. Now here, when we have an operation which is multiplication and division, we have to do from left to right. Those are the rules. So you need to multiply these and then divide by this. It is as good as writing 6 square root 50 times 2 square root 18 divided by 3 square root 27. Is that clear to you? Very important to understand. Correct? 50 can be written as 2 times 25. So we get 6 times 5 square root 2 times 2 times 9 times 2, 3 square root 2. 27 is 3 times 3, 9, right? 9 times 3 is 27. So we get that as our result. Let's try to simplify this. We can cancel this 3 with this. This goes 2 times, right? And what we have here is 2 times 5, 10 times 2, 20. Square root 4, square root 2, square root 2 will be giving you 2. Divide by square root 3, right? So we get something like this, which is 40 square root 3, right? Now let me add a step here. Most of the time, we don't leave the radical in the denominator, and we call it rationalization when we multiply and divide by square root 3. So here I'm adding one step, which is called rationalization. We don't want to, it is not a good practice to leave something radical in the denominator. So what we do is we multiply and divide by square root 3, which is as good as 1, correct? So when you do that, this becomes 3, right? So we can write the same thing as 40 square root 3 over 3. Do you see that? So this is a better answer than the one which we had arrived at earlier, right? So earlier we were writing 40 square root 3, correct? So you'll prefer this answer over that. It is important to understand, since in many multiple choice questions, you may have that choice and not this, correct? Now let's see how to find powers. Cube of this. Now cube really means, we could write this as minus 3 cube times square root of 2 cube, right? So that gives you minus 27, and that is cube means 2 cube, right? So 8. 2 cube is 8. Now 8 can be written as 2 times 4. So we can write this as minus 27 times 2 and within square root 2. Now you understand how to write this as a mixed radical, right? So the answer now will become minus 54 square root 2. Is that clear? The next question is, you have to do the operation as you do in polynomials, right? Just multiply and expand. So with 3, when you multiply, 3 times 2, we get 6, right? So we get 3 times 2 as 6. Then 3 times square root 6, we get 3 square root 6. When you multiply by minus 2 square root 3, then 2 and 2 get multiplied, but the sign will be negative. 4 square root 3. And when you multiply this with square root 6, then within the radical sign they get multiplied. We get minus 2 square root 18, right? Now, we can write this as 6 plus 3 square root 6 minus 4 square root 3. 18, you know, can be written as 9 times 2. So we get 2 times 3, 9 square root times 2. Now we don't really have any numbers to combine here, so we'll write as such whatever we are getting. We get 6 plus 3 square root 6 minus 4 square root 3 minus 6 square root 2. That will be our answer. Is that clear to you? Correct? Okay. When you do square, the same thing is to be multiplied, right? So you could use the quadratic formula also if you want to, which is a plus b whole square is a square plus 2ab plus b square, right? But if this is minus, if one of them is minus, then that will be minus. In our case, we have minus 5, right? So we'll get square of this, which is 25. Let me write minus 5 square minus 2 times, this minus because of minus 5, times 3 square root 2 plus 3 square root 2 square, right? So that gives us 25 minus 10 times 3 is 30 square root 2 plus 3 square is 9 and square root of 2 is 2. So we can combine these terms to write down our answer. We have 25 plus 18 minus 30 square root 2, which is 8 and 5, 13, 3, 1. So 43 minus 30 square root 2 becomes our answer. Clear? So the same thing here, let's do it. So we get 1 square, which is 1, minus 2 times 1 times 5 square root 2 plus 5 square root 2 whole square, right? So we get here 1 minus 5 times 2 is 10, 10 square root 2 plus 25 times 2. And that is 1 plus 50 plus 10 square root 2. Or we can write this as 51 plus 10 square root 2. Perfect. Now we have thinking and application questions 6, 7 and 8. So we'll use some of the strategies here to answer these questions. We need to simplify square root of square root of square root of 729. Okay. 7 to 9, 7 plus 2 is 9 and this is also 9. That means you can divide it by 9. So let me factor 729. So if I divide by 9, 9 times 8 is 72, we get 81. Then we have 9 times 9, correct? So we get 9 to the power of 3 as 729, right? So basically, as you see here, this is equals to 9 to the power of 3. Now 9 is equals to 3 square, correct? So 9 to the power of 3 will be 3 to the power of 6. That is what we are going to use. So the other way to look into this radical is, we could write this as 729 to the power of half. That is what radical means, right? To the power of another half and then another half. So those are the halves which are one over the other, right? These are the powers of half, correct? So we have 2 times, we'll do square root, and square root, so many times, correct? To get our answer. So, or you can do from inside out, we got these 3 9s, and we can also work on this, writing 729 as 9 square, and then we can figure this out. Or we can also think about this as like this. So let's do 2 ways. Let's do 2 ways. So we'll do this like this. Square root of, let's say square root of, and here we have 9 times 9 times 9. Is that clear to you? Which means 333, right? So we have square root of 3 times 3 times 3. Right? So when you have the square root here, then one of the 3's can come out. So we have square root of 3, and something like this. So that becomes your answer. Correct? So that could be one of your answers. The other way could be that we have written this in this form. That means 729 is 3 to the power of, so that means 9 to the power of 3 is 3 square 3 which is 3 to the power of 6. So I could write this as equal to 3 to the power of 6, everything to the power of 1 over 8. Do you see that? So when you do this math, 6 divided by 8 is your answer. 3 to the power of 6 divided by 8. Or you could write this 3 to the power of, dividing both by 2, we get 3 over 4. So both could be the correct answers. So either way, you could work with this. So I hope, slightly difficult to understand at this stage, but I hope that gives you some idea about sometimes working with radicals could be complicated. Okay, let's move on and take question number 7 now. Question number 7 is x square root equals to x? Justify your answer. Most students will say yes, correct? Okay. But it is not really true. The answer here is false. Can you tell me why? Okay, let's take a case. If x is equals to 4, right, in that case, square root of 4 square is equal to square root of 16, which is equal to 4, right, which is same as x, correct? We started with this, we got the same thing. But imagine what happens when x is equal to minus 4. In that case, we have minus 4 square, and we get this also as positive 16, and that is also 4. But this is not equal to x, because x is minus 4. So therefore, square root of x square equals to x is wrong. So what do you want to learn from here? So we learn that square root is always positive. So square root of x square is equals to absolute value of x, not just x. Not just x. Now here is the last question, question number 8. Is square root of x square plus square root of y square less than equal to x plus y square roots whole square for all natural numbers, right? So we want x and y to be greater than 0, all natural numbers. Okay. How will you prove this? Well, let's begin with the right hand side, which is square root of x plus square root of y whole square, right? So I could write this as this square plus twice ab, which is 2 times square root of x times square root of y, plus that square. Now clearly you can see that we have these two terms, right, plus something positive. This is always positive, and therefore we can say this is always greater than, or it could be equal to, if, right, but it is always greater than, for sure, square root of x square plus square root of y square. Is that clear to you? So that is how you can prove it. Since I took natural numbers, you could take 1 as the base, right? So 1 plus 1, if you do that, 1 plus 1, right? And here we have 1 plus 1. So here the answer will be 2. Here will be 2 square, which is 4. And if you take more numbers, you will realize that this is always true. Mainly because we have a term here, which is positive, right? 2 times square root x times square root y. And that makes it bigger, right? By that factor, right? So that is how you could answer this question. So I hope with this you have understood how to work with radicals, I should say square roots mainly. The idea is to do better for quadratic functions. So after this we'll take up quadratic equations, but that gives you a good base. Perfect. Especially the last 3 questions were pretty interesting. Try to take them on yourself and then see if you can easily solve them. Thanks for your time and all the best.